So today we are going to have not a very long lecture, very small lecture, and it's not included. I'm not going to ask you to do this for your project, but I'm going to introduce you to other tools that is being used in the to do flood risk analysis or to do any natural hazard risk analysis. So just before I start, let me record my screen. Does anybody have any questions about the project, about anything before I start?
I completed writing the code,
Okay.
but when reading shapefile, it gives an error for S100. Probably it's missed, or maybe you gave
Oh
me
yeah,
the
yeah.
other name.
S100 is the same file of the original one, the base flood loss, because that's the 100% of the building was. You remember we have all the buildings, and then I tried to subtract, but the thing is, when we do the loss and the base loss analysis, is based on the 100% of the building. So you can read the same base shapefile. Okay, so that's for this building. I believe I didn't upload the template, right? The ASCC template. So I'm gonna upload it. If I didn't upload it today, somebody send me an email so it can remind me. And I'm gonna upload the. It's basically like a Word file that you are gonna just like copy paste what you are writing in. So it's 2 columns. It's designed based on the ASCC 7 format. All right. So what I want to do, what I want to say today, I want to say that what we have done, that's the base for any flood loss analysis software. Like if you, I know somebody here in this class were able to develop an interface to what we have done. Like basically, like any risk modeling company, it's doing the same thing, but the thing is, all what we are doing is that in the back end of the software, you don't see it. So it's like working with SAP 2000. You define an element, you do something in the software, but you don't see what is happening behind the software. What's happening behind the software is all the coding that we have done. Any risk modeling company, RMS, VRisk, all these companies, they use their own tools, and their own tools have something similar to this. There is definitely a way to read hazard maps. There's definitely a way to read building inventory. They use their own vulnerability functions, and they run their own flood risk modeling. So what we have done is a base for many tools that do risk analysis. Some of these tools are only tools that can only single companies can use, and you cannot have access to this. It's only for the company use. And there is some other tools that developed like federally and are available for researchers to use them. So what I'm gonna do today, I'm gonna show you how other tools look like. There is one major tool that do risk analysis in a way that we have done. It's called HAZUS. So if you go like to Google and search, for example, HAZUS multi-hazard MH. So you go here, try to follow what is inside the website and try to download the software. So I believe it's 4 GB. So just go here, read the technical manual, and maybe you read the HAZUS loss library, what models that they are using. They are used completely different models from the one that we are using. But believe it or not, it's the same sequence. They have their own hazard, they have their own building inventory, they have their own vulnerability functions, but it's the same process. You have to have a hazard, you have to have a building inventory to lay them together and identify the hazard intensity at each asset, and then use a vulnerability function to identify the damage or the losses at each asset. That's what HAZ is doing. But the thing is, they use different hazard models, different building models. Sometimes they don't do the analysis at the building level, they do it at the census block level, so that they don't release information about building. But actually, in HAZUS, you can modify what you are doing and upload your own data. Like you would tell HAZUS, I don't want to use your hazard map, I want to upload my hazard map. I don't want to use your building inventory, I want to upload my building inventory. So if you are interested, by the way, this is very, very significant. If you want to be a risk modeler one day, doing this stuff, you have to understand what HAZIS is doing. Okay, you have to understand what other tools they are doing. Okay, so you can go here and read the HAZIS technical manual and how to install the software. I tried actually to get the software. I already have the software working on it. I tried to open it, but the thing is somehow there's some errors, I believe, because I used to do this like 5 years ago. And the thing is, when you open HAZIS software, it do, like it says here, it does earthquake, wind, flood to tsunamis. It's the same sequence. And basically, once HAZIS open, it's gonna ask you what region that you wanna do HAZIS analysis for, identify the county, identify the hazard, and you will have to do them. Oh, it sounds like it. What's my phone? Yeah, it sounds like there's an error. It says cannot open database. Yeah, there's maybe some files are missing. But anyway, it's gonna ask you if you wanna create a new region, and then you create a region. But the thing is, you need to read the manual, because before you create the region, you have to go to HAZIS website and download the state data that you are working with. So once you go to HAZIS, you search, for example, Florida, and you download the state of Florida, and you have to save it in a specific file. And once you pick a county inside Florida, it's gonna go to the file and pick the data for this county. Okay, so that's for HAZIS, but I'm not gonna discuss HAZIS today. But HAZIS is one of the most significant tools for risk modeling, and many people or many researchers who do research in the stuff that we're working in use HAZIS as a benchmark. When I developed my first papers in my PhD and I developed these vulnerability functions, I compared them with HAZIS. What is my function is doing, and how is HAZIS functions doing, and how they are close to each other. Okay, so many people, they use it as a benchmark. Okay, so this is for HAZIS. Maybe you spend a few hours, go check what HAZIS is doing and see what models that they are using. They have really good manual. So maybe you check the manual. They have manual for wind, manual for flood, earthquake, to tsunamis. And the interesting thing is, and that's actually what inspired my research in my PhD, that HAZIS use for earthquake and wind, they use fragility functions. So there's an earthquake fragility functions and there is wind fragility functions. But for flood, they don't use fragility functions. They use something that's called a stage damage function. It's basically a loss curve. So that's what made me ask questions. Why there is no flood fragility functions? What makes it hard for HAZIS to use it? So I got inspired that it wasn't there. So I started to dig until I got like area to work on related to flood fragilities. And by the way, once we developed them, we communicated with HAZIS and we had open communication with them. And we inspired them that they can move from stage damage functions to fragility functions. They are still actually working on it. We give them all the data that we developed. That's also something that they do. Okay, so that's for HAZIS. I told you will have to define the region, name the region, do whatever like in the manual saying, but this is not what we're gonna do today. What I'm gonna introduce you today is a tool that uses the same things that we did in the class. All the hazard map that we use, or the hazard map that you use to develop the damage models, and use also the building inventory that we have, and also use the same fragility functions that we have. And this is actually the tool that funded the research that developed these fragility functions. It's called INCORE. So if you go on Google and search tools INCORE, yeah, this one. The first one, INCORE. So basically, before you start doing, go to INCORE, you have to create an account. So you will say login, and in the login, you say I want to create a new account, and you have to put your information, and you're not going to get that account right away. Maybe after a few days, the admins because this software is run or on a servers in a supercomputer in University of Illinois Urbana-Champaign, and they are controlling the whole thing. They have to give you access. So basically, you have to submit your information. In a few days, they might give you access to the software. It's for free, for now at least. So that's the first thing that you have to do, is to log in and get an account. So, and give it a few days until they give you access to the account. So once you get access to that account, somehow my account is on hold. I wasn't able to access my account. But the thing is, at Web Tools, once you get an account, you will find something that's called DFR3 viewers. In the DFR3 viewers, that's a fragility viewer. You are gonna find all the fragility that we have developed, or the one for 15 building archetypes. You will find all of them. And for this viewer, basically, because in fragility viewer, you will find hundreds of fragilities, earthquake to tsunamis, flood, hurricanes, you'll find many of them. So when you open this one, try to select that you want the flood fragility, or even search my name, no fault but my last name, and you are gonna find all the fragilities that we have developed. That's for this. So you will find the web tools. They have fragility viewer and they have data viewer. Data viewer is for buildings. So basically you will find all the buildings. Just search Lumberton, you will find all the buildings for Lumberton in the data viewer. Hazard viewer, you will find the hazard map for Lumberton that I give to you to do the base flood loss analysis. And the data set type viewer, you don't need this one, but this is the main three data that you want. The buildings, you are gonna find them in data viewer. The hazard, you are gonna find it in hazard viewer, and the fragility, you are gonna find them in DFR3 viewer. But until you get your account activated, go to the user guide here and go to Encore Manual. Because in Encore Manual is gonna guide you step by step how to access everything in Encore, what is Encore doing, what kind of library. It's a Python-based tool, okay? So you are gonna find it's based on, they have their own package. It's called By Encore, okay? So basically, this manual is gonna tell you how to access this package, how to install it, and what kind of Encore web services. Encore web services is the fragility, the data, everything that I showed you a few minutes ago, and what tools they have, and also they have their Encore lab. What is Encore lab is? So in Python, there's a Jupyter notebook, and there's something, it's called Jupyter lab. It's basically, it's something like MATLAB, but it's just for Encore. It has all the packages and all the functions that you need just in Jupyter Lab. It's something, Jupyter is one of the platform that you can use Python to write Python codes on. So they have a sub Python platform, it's called Jupyter Lab, that you can write your own code at. Okay, so this is the introduction you are gonna read to understand what is By Encore, what is Encore Web Services, and also you will find some examples of communities that By Encore or Encore used for. You will find one of them is Lumberton, the test bed that we worked on. I developed this one, and I developed this one too, Galveston and Lumberton, okay? All right, so to make an Encore account, so basically it's gonna tell you step by step how to create the account. And once you create that account and you wanna get it started and get Encore ready, it's gonna tell you how to get Encore ready on your local machine. This is a step by step. It's basically, you have to install a software, it's called Miniconda. And this software, it's like, do you guys remember the black screen, the prompt screen in Windows? It's like a black screen and you write some code on the black screen. And this black screen, you're gonna write some commands. These commands, you write them the way they are here to install the packages and update the Python and the By Encore software to activate the By Encore environment. So follow these steps and these commands one by one. All right. So once you follow all of these, you will have all the package is ready to write your own code. Okay. So yeah, this is just like telling you how to get started with By Encore. And here It's gonna show you some references, some stuff if you wanna know information about how to test, how to upgrade, how to install everything on the software. But what I wanna talk today is the examples notebooks. So I'm gonna skip all of these and I'm gonna go to the example notebook. And in the example notebook, if you wanna see the analysis that you have done it on MATLAB, and here you go access Lumberton testbed. Okay, this file has all the data file that is needed to run this Python code. All right, so you'll find all the data, the fragility, the JSON files, of everything. And if you go to the Lumberton testbed, I'm giving you a background of the Lumberton, everything about it, what we are doing, what is the publications based on this Jupyter notebook. If you want to read more about how the hazard maps was developed, how the fragilities was developed, step by step. And I'm talking about Lumberton, how it looks like, and the work in progress at that time. By the way, at that time, yeah, like right now we are done with the household unit allocations and the population dislocation. So all this work is done. I believe we're gonna publish it soon. And these are the publications at that time that is based on this analysis. And by the way, this is not only flood physical damage analysis, but also we did population dislocation analysis. So we did, I'm gonna tell you a little bit about the population dislocation analysis. Here it tells you what is the prerequisite to run this code. So I'm talking about something that's called by Encore. You have to update for these versions. And here is the first step, how to do building damage analysis. So definitely Python is a completely different language from MATLAB. So I'm not sure how many of you are aware with this tool, but the thing is you have, before you use any functions, you have to import all the packages that you are gonna use. Like I'm gonna use PyEncore, so I import from PyEncore some stuff. I'm importing data sets, fragility services, mapping services, data services. So you import libraries so that you can work on later. Same thing, and from each library, like you wanna import, for example, building damage. So basically this is some stuff I write at first because I'm gonna use them later. I'm gonna use, for example, NumPy to do some mathematical analysis. I'm gonna use GeoBandits to do some geographical or to show some maps. So these are libraries that I use to run my analysis, not like MATLAB, that the library are already on the side. By the way, there's some libraries that are not in MATLAB and you have to install them to use them. Like there's something that's called mapping tool. If you want to show maps, you have to install it separately. There's something that's called Simulink, electrical and mechanical engineering uses, so you have to install it. If you are going to use a machine learning in MATLAB, you have to install, I don't know, like some tools that you have to install. Same thing here. If I'm going to use, I don't know, like machine learning algorithm, I want to do something else, I have to import a machine learning like PyTorch or whatever library that I'm going to work with, and you put them here, okay? All right, so I'm just preparing my code, and the first thing that I do here, I create a data service, and this is like kinda a programming schema that Encore is designed for. Like you import the data service in Encore and you print the Python version to make sure that the versions are up to date. And then is the flood hazard model. The flood hazard model, basically, we don't develop it in Encore because Encore doesn't do hydrodynamic analysis. So there is some hazard maps that Encore can develop, and like earthquakes, tornadoes, because that's an easy hazard maps that can be developed manually. Basically, they relate a seismic source with some soil information to develop a seismic hazard map. But for flood hazard map, it needs a very extensive hydrodynamic analysis, and this part is not into Encore. So what we do, we develop these hazard maps outside, and we have the raster map, and basically embed this raster map in the back end of the tool, and you just recall them. So basically Encore doesn't develop them. You develop them separately on a software, and then once you get the raster map, you give it to the software before you start the analysis. So basically, that's what I did here. Like if you look here, this ID basically is the ID of the hazard map. Anything that you upload to Encore, it has what we call unique ID, right? It's gonna have a number. If you develop a fragility, it's gonna have a number. If you put a hazard map, it's gonna have a number. If you put data, it's gonna have a number. So basically, you're saying that what kind of hazard that you're gonna work with, I'm gonna work with flood. So basically, Encore is gonna prepare itself to do flood damage analysis. And then you read a flood depth hazard map. So basically, you read the hazard map that has this ID, and this ID is related with an uploaded file into the data service inside Encore, okay? All right, so, and then here you just like give it some information, like base the file name is flood inundation depth speed data set, and get the file, and the file extension is TEF, which is a raster map. So this is for this part. I believe that's the same thing. Yeah, and here, reading the hazard type. So basically this part is just to read the hazard map. So what I would do actually, if I want to do this, I know this is not part of the project, but it's really, really good exercise. If you get your Encore, if you get Encore ready in your machine, on your computer, and you follow all the stuff into getting started, and you have the Python code ready and the packages ready, try to copy paste these codes. Copy and run and see what you are gonna get. Okay, copy these codes and run them. And so this is for the hazard maps. So once you run this, I'm not sure, it's not gonna show you the hazard map, but the hazard map is already embedded into the system. If you wanna see the hazard map, you can go here, Web Tools, and go to Hazard Viewer, and search with this ID. Copy this ID, the hazard ID, and then you are gonna see what this hazard map exactly is, right? For building exposure, the analysis is based on the 15 building archetypes that I showed them to you before. And this is the description of each archetype. And these archetypes are already uploaded in the building inventory, and they have an ID. This is the ID of the Lumberton building inventory. So basically, this ID is connected with a shapefile. Okay, and you are gonna write a visualization code, this code, to visualize. It's called visplot, and it's gonna show you where is the location of Lumberton and the buildings color coded based on their archetypes. So basically, Lumberton is here, and these house the buildings around Lumberton. And here it's going to show you, this is a summary of the shapefile. So basically, it's just showing you what is inside the shapefile. This is the GUID of the buildings. This is the structure ID. There is vertical floor elevation. It's not going to show you the whole shapefile, just a little bit of summary about the shapefile. The vertical floor elevation, the structural type, the number of stories, and definitely you can scroll. And by the way, the thing is, the problem was Encore. The problem with Encore is that you have to give Encore the data, the shapefile data, in a schema that he can understand. What does the schema mean? Can you see this shapefile? Like for example, can you see FFE underscore elevation? It needs to have the field named by this name. If you have FFE and without underscore elevation, it's gonna give you an error. If you have FFE capital, it's gonna give you an error. So that's actually, I think it's one of the worst problem of this software is the schema you have. Like I give you a shapefile, or the city give you a shapefile. You have to adjust this shapefile to create the columns that Encore can read. If you give Encore the columns in a different way or a different names, it's gonna give you an error. So that is the first thing that I had to do before I give this data to Encore. So I talked with the people from Encore. I told them this is my shapefile. They gave me the schema shapefile that Encore can read, and I have to adjust my shapefile, rename all the columns, all of them. I renamed them, deleted all the columns that are not in the schema, and then I give them a new shapefile that Encore can read. I know other tools started to do something, it's called mapping. Basically, you upload your own shapefile that has whatever names that they have. And the software is gonna keep asking you questions because the software doesn't know where's the first floor elevation, where's the building archetypes. So it's gonna tell you from the shapefiles that you gave to me, where is the FFE? You tell him the FFE is in this field. Where's the building archetype? The building archetype in this field. Where is the foundation type? It's in this field. Where is the roof type? It's in this field. So basically you keep matching what the software, because you need to guide the software doesn't know. If you put the field name any differently, it's not gonna read it because it needs to be exactly the same. Do you guys understand this? So it has to be the same schema that the software can read. All right, so this is for the building inventory. The next step is the fragility vulnerability modeling, fragility based. So I put all the equations, if you guys remember from the PowerPoint, I had these equations, how to do, this is, do you remember, if you guys remember, this is the total number of simulation, this is the number of fails, and we get the probability of failure based on the number of fails over the total number of simulations and the loss analysis and everything, and I put the damage state, so I put description before I run the damage analysis, and this is the fragility, the loss function. So before every piece of code, I put a description, what is this code is based at. And if you guys remember, we did a log normal fitting, and the log normal fitting has lambda and XC, but for Incore, when we first developed the Incore, we had 5 damage states, 0, 1, 2, 3, and 4. Then they come up later, they said, oh, that's too much damage states. And we need to be, we need to adjust the damage state. To be honest, they told me we need only 3 damage states. We need damage state 1, 2, and 3. And basically, it was like a slight, and medium and complete, moderate and complete, 3 damage state. So I have to redevelop the fragility. Basically, I merged the curves together. I merged the damage state 0, 1, and 2 in 1, and the 0 and 1 in 1 damage state. 2 and 3, they become 1, and then 4 become damage state, something like that. But to be honest, I don't like this to be that way. Like merging damage state 2 and 3, I believe it's not good. So, but I did what they want, because the thing is, they need it that way because they want to have a generalized tool for all the hazards. And the fragilities from the earthquake was like that way, and the tsunami that way, so they wanted all the fragilities to be consistent for all the hazards. So that's why we did it that way. But from my perspective, maybe I would take out damage state 0, but I need to have at least a slight, moderate, extensive, and complete. This is how the damage is propagating, or how the damage is escalating from having a little bit of damage to moderate, extensive, and complete. That's from my perspective. Having 4 damage state is the best. All right, so they have here the fragility curves, and basically they have a mapping ID. You guys remember, we need to map each fragility to the archetypes that match this one. So they have something, it's called mapping. And then once it's mapped, we do the building damage analysis, and this is the flow chart showing how the building damage analysis is done. By the way, if you can see here, we do it from 0 to 4. That was in the base. That means the tool, the original one, was based on damage state 0, 1, 2, 3, and 4. But then later they changed it to 1, 2, and 3, just 3 damage states. All right, so here it calculates the building damage. Basically, you import the buildings, you import the mapping of the fragility, fragility 3 mapping, and then you write this code, building damage. So basically, you don't write all the codes that do you guys remember when we have a code that calculates the probability of exceedance of each damage state? We made a for loop, and we calculate the exceedance probability of damage state 1, 2, 3, and 4. We don't write this because this code basically do this in the back end. This one, you basically tell this code where is the fragility, where is the hazard, where is the everything, and then it use this in a service that run the damage and put them in the results.
So at the end, you are gonna have the building damage results and here, something like this, and it tells you LS is the limit state, and then you are gonna have limit states 0, 1, 2, and you are gonna have damage state 0, 1, 2, and 3. So basically, if you have a 3 fragility curves, that means it's 4 damage states. Do you guys understand this? It's a 3 fragility curves. So if you have 3 fragility curves like this one, this is the depth, and this is the probability, okay? So the 3 fragility curves is fragility curve number 1, number 2, and number 3. This is the fragility curves. So that's damage state 1, that's damage state 2, that's damage state 3. That's the curves. But the curves have 4 regions in between them. 1, 2, 3, and 4. Okay? So this is damage state 3. This is damage state 2. This is damage state 1. This is damage state 0. Which is no damage. Okay? No damage, damage state 1. Because if you are here, you either exceeded the damage or you didn't exceed it. And if you didn't exceed it, that means you don't have damage. Okay? That's what we have when we have 4 fragility curves. If you guys remember. We have 4 fragility curves. 1, 2, 3, and 4. You have 0, 1, 2, 3, and 4. All right? And there's one that has damage state 0. It's called insignificant damage, which is very close to no damage. Insignificant damage that's like 1 or 2%. You can basically, and that's only was for 2 archetypes. The archetype that has a crowd space foundation, archetype 1 and archetype 3. Okay? So this one is the no damage. Alright? This one. Then you have damage state 0, insignificant damage. Then this is damage state 1, which is a slight damage. This is damage state 2, which is moderate, extensive, and complete. But the one that is here, no damage, and I believe this one is like slight to moderate, this is like moderate to extensive, and this is complete damage. All right. So it gives you the results, and also tells you something, if the building is exposed to flooding or not. It says hazard exposed. If it's no, that means it's not flooded, there's no water touching this building, and if it's yes, it means that there's water touching this building. So that's as easy as that. Like that, right now, you are done with the damage analysis. So the damage is done. So basically, you go download the software, understand what everyone, and you can use this for many downstream analysis. Like there's a lot of research based on this one. Like this one is a complete social science research that is based on the damage analysis that has been done over there. There's an associate professor at Texas A&M developed a housing unit allocation and housing population dislocation model based on the damage. Basically, he relates the damage states for each building with the population characteristics of the people that live in the building, and develop the code and says if this house has this amount of damage, and if this household, for example, they have this race and this income and this level of education and this household size, and if they are owner or rental, they are gonna be dislocated or not. Because that makes sense. Like let's say your building is damaged state 3, you have an extensive damage, that means that the water got here. Whatever your race is, you are gonna be dislocated, right? But let's say that you have 2 inches of water inside your home. Well, it depends on your income level, it depends on your race, depends on many things. Are you gonna leave your home or not? Are you gonna get dislocated or not? There's some people that they cannot tolerate flooding. Oh, my house is flooded. He don't care. He just leave and go live in a hotel until he brings somebody to dry out the building. But there's some people, they cannot afford living in a hotel, so they will dry and just live inside their house. Okay, so based on the level of damage and the social characteristics of the household, he was able to do this. But the main thing is, how can he know the population characteristic in each house? The thing is, he used data from the census data. And census data basically provide you with detailed information about the population characteristics, but not at the building level. Like, why? Because they don't release people information. Like, you don't want anybody to have access who live in this building, how many people live in this building. That's really, really sensitive information. So what they do is, they aggregate this data at the census block level, like maybe a block of 20 buildings. They tell you in this 20 buildings, there's 250 people lives, and 200 is adult, 50 is kids. And their age group is this, their income level is this, their race is that. So we tell you all the information, but in an aggregated format, not at the building level. That's what census data is. You can really access this data. Like, you can, and you can download them in a shapefile format and stuff like this. Like, if you go search, for example, census data viewer, see, demographic data map viewer. Somehow in this website, let's see. Yeah, there is restricted data summary files, demographic and housing characteristics. Yeah, this one, the demographic and housing characteristics file. So yeah, somehow you will follow this and you can access this data. That's what we did in this research. And then he was able to access the census data, but the thing is, we need information about the household, not at the census block level. I want to know, and not at the building level. We need it at the housing unit level. Like, let's say that we have a multi-family home that has 20 apartments. We need to know how many people live in each apartment, each housing unit. So he was able to use information about the addresses. The thing is, what we have right now is buildings, right? We didn't have housing units. We only care about the building as a one building, one piece. If a building has 2 units, like sometimes there's townhomes, that are maybe one strip of a building has 50 townhomes, or I don't know, 10 townhomes. We are interested at how many people live in this whole building, okay? And what are the races, what their income, what is all the social data about them. So he developed something called synthetic household synthetic allocation algorithm. So he synthetically used a Monte Carlo simulation and probabilistic analysis to assume, let's say I have a census block that there's 20 buildings in this block, and I have 250 people. How I can allocate these 250 people to each building? So he synthetically allocated them. Is that true? No. But the thing is, when you aggregate them, it's gonna give you the 250. Okay? So he basically distributed them, and not only this, he was able to tell you, are they renter or owners? What are their rates? What are their income? What their educational level? What is their age groups? How many kids do they have? So all this information was there. And based on all this information, he was able to get done with the housing unit. He didn't do any population dislocation until now. Right now, he just allocated household to each building. And he writes this code, maybe you will read it. He used this data. Data is called housing unit inventory. What we have is called building inventory. Building inventory is completely different from the housing unit inventory. Why? Because I told you, maybe one building has multiple housing units. So that's why he needed something called the housing unit inventory, and he got it from the 2010 US Census block level data. Then he used another set of data, it's called address point inventory. So he used a list of all possible residential house and businesses addresses points in a community. So he was able to get this data, and at the end he used the building inventory data that we have. Okay, so at each one of these data sets they have an ID. He was able to have them and upload them, and he did the coding that related to run the housing unit allocation model. So this code is standardized into Incore. So it's one of the, I believe, one of the most systematic code in Incore right now. Basically, you give Incore the housing unit, the address, the building inventory, you run their own model, and he allocated household to each building. Okay, so this is for this one, and at the end he would explore the results, and that's actually this is the body of the code, how he allocated housing unit. Like if you find some stuff are related to race, you'll find here something is called Hispanic, race ethnicity, white alone, black alone, American Indian, Asian alone. So he's do a lot of stuff. The tenure status mean if it's owner or renter. So that's something that he's doing, and the ownership. And then at the end, yeah, it's a really, really long code. I don't want you to get into it, but the thing is, that's how he did the population allocation. At the end, it gives you a summary. It tells you how many owners, how many renter, and the total household. How many of them are white and not Hispanics? How many of them are black alone, not Hispanic? American Indian, Alaskan, Asian, all the races, and at the end, that makes the total population of 46,861. So he was able to allocate this population. And then right now he's validating his population allocation model. And you can visualize them at the end in a heat map. Like in a heat map, once you run this code, it's gonna show you a heat map showing you where's the most people live. It's gonna give you a red spot with a lot of people here. And then he did another code for population dislocation analysis here. So basically, yeah, this is the results. Yeah, here at the end, it would tell you if the household is gonna be dislocated or not. So if it's false, that means it didn't dislocate. If it's true, that means the household got dislocated. I also developed one for schools, explore population dislocation results by school, like if, oh, it sounds like there's a lot of update here. Yeah, so basically, it's gonna tell you, based on the damage state of the building and the household characteristics that we have. By the way, I don't have to understand everything in this code, but I have to understand the input and the output, and this is something that you have to learn while doing your research. There's some codes that you don't have to understand all the aspects of it. You have to trust the code. You have to trust the person that developed the code. And you have to understand what kind of input that you need to run this code, and how does the input look like? And you need to have the common sense to judge the final output. Because let's say, for example, this code give you for a household that got damage state 4 that got dislocated. That doesn't make sense. Damage state 4, this building is completely damaged. There is no way that the household can stay in this building. So that's the common sense that we're talking about. So writing any code in general, you have to use your common sense, because that's a programming language. It takes some cycles to catch the bugs that you have. So you give an input to the code, you get an output, you have to judge the output with the common sense. You cannot put the output right away. You have to read the curve. Oh, this curve doesn't make sense, because it cannot, like let's say you are running a loss damage analysis, and when you run the loss damage analysis, it gives you losses 180%. Does that make sense? Doesn't make sense, right? Why? Because the losses maximum that you can get is 100%. There's no way that you are gonna get more than 100%. Unless there's a conceptualization behind this, right? So, I mean, if there's somebody that can justify this, that's fine, right? But you have to use your common sense, because So what I'm saying here, in population allocation or population dislocation, if you want to understand them, how these codes was developed and how's the process, there's a couple of papers here that I put them at the early verse. Nathaniel published them. You can read them and see how he developed his codes. But once you understand the method, then you don't have to every time to write the code again. You can use it, give the input. The input is the housing unit, the address, the building inventory. This is the input, give the output. That's it. That's what I do in my research. I don't have to understand all this code. All what I have to get the input right and give the input to the code and get the output. Try to use my common sense to judge if the output is right or not. And if it's good, I can like use the output in the next level of research. All right. So that's, I believe, really good exercise. If you want at some point, because that's, you can publish a paper. Most of the journals right now are looking into interdisciplinary research. All what we have done is one discipline till now, is doing civil engineering research, having flood hazard and getting damage. But if we take it to the next level and see how this is impacting the population, that's add more strength to your research, and that's what this piece of code is doing. Because mostly we are looking for human impacts. Why we are looking for damage? Because we need to see how this is impacting people. Okay, so that's what it's gonna do. And take it not only for buildings damage. Let's say that you are doing research on bridges, and in bridges you are trying to find how. Look, I did a research on a bridge, okay, and I did fragility analysis, and I got the probability of failure. You can connect the failure of the bridge, how it's gonna impact the functionality of the whole transportation network. Because if this bridge is not working, it's gonna impact the whole transportation network. And people have to look for a different path, and how is this different path is affecting the people time, and how this is gonna impact the work productivity. So you can take the bridge failure to how it's impacting the whole transportation network, and how this transportation network is impacting the population. Okay? So that's how you can see human impact on the research that we are doing. And by the way, we have done that. There's a paper, if you want to read it, we published in 2023. This, not this one. Yeah, this one. Can you see how many people? Like 14 people in this paper, because it's interdisciplinary research. It has structural engineers, it has civil engineers, infrastructure engineers, it has social scientists, economists, a lot of people. All right, so let's go to the method. So basically, we shifted from the fragility analysis that we have to something that's called functionality curves. The thing is, fragility tells you how much damage that this building is going to have, but we shifted from how much damage to how functional is the building is. And the functionality is the building usable? Is it restricted entry, restricted use? So based on the damage, we were able to say if the building is functional or not. The thing is, if you have a slight damage, we can say that the building is functional. But if you have extensive damage, definitely the functionality, it's, basically this tells you the safety. Look, here you will find the damage is slight, moderate, extensive, complete, and on the right side, there's restricted entry, restricted use, restricted occupancy, limited occupancy, and operational. That's the functionality states, if the building is operational or not. And that's actually what we are interested in. We need to know if the building is functional or not. Maybe not the damage. We need to know if the people can stay or not. Okay. So here, I want to see you some results. I want to show you some results, and also that it has an in-core model. This is the flow chart that we connected all the models together. And this is the housing unit allocation that I told you about, the census plot data, and how we can allocate census plot level data. Like if this census plot has 100 people, how to allocate them to each building. And this was done for Lumberton too. And this is the network analysis. This is the power network. We tried to map the power substation and the power plant. This is the power network analysis, and this is the transportation network. It shows where is the gas stations, where is the schools, the hospitals, the shopping centers. And we have done, here it shows the exposure analysis, which buildings are exposed. This is the shows you where's the flooded water network, the flooded transportation network, the flooded power network. And this is the functionality analysis, the building functionality state. This is the water availability. Which building has water and which doesn't have. And which building has power and which buildings that doesn't have power. The one that are in red doesn't have power, and the one in green doesn't have do have power. Okay, same thing with water availability. And we did transportation network analysis. Look at this. For the transportation network analysis, based on the flooded roads, we were able to know the accessibility time with flood and without flood. Like here it shows how many seconds it's gonna take you to go to hospital with no flood, and this is with flood. And this is how much time it's gonna take you to go to a gas station with no flood and with flood. Same thing with the schools. Here, time to go to shopping centers. How much time you are gonna take with and without. And based on this, we were able to have an idea about the total functionality of the building. And we get a final percentage based on the damage, your accessibility to your work, to your shopping center, to gas station, to schools, if you have power, if you have water. So one single number can tell us all of this. So like for example, this building, even it's not flooded, look, there's not even water there, but it has 60% functionality. Why? Definitely doesn't have physical damage, but it doesn't have water, it doesn't have power, maybe he lost accessibility to his workplace in the flooded area, and maybe his kids cannot access the school in the flooded area, so his functionality dropped to 40%, and he didn't even got flooded. So that means not being flooded is not like you are survived. You still got affected by the flood somehow. Unless you live very, very far away and you have nothing to do. It's something like a flood happened in Mississippi, it doesn't affect us because we don't work there, we don't send kids to school there. Or maybe, let's say not Mississippi, Orlando, a flood happened in Orlando, it doesn't affect us. It's gonna affect the cities around it because people live around the city and they go to work, they use the transportation network. So all of this got captured here. And you see, the more that you get away from the flooded area, the more you have increase in the functionality. Like look at this one, it has 88% or something, okay? And definitely there's some people have a combination between like the one in the flood area. They have everything, they got flooded, they lost power, they lost everything. So this is just an example of how to use all this information in research, okay? So that's the end for now, but I just want to say at the end, I tried in this class as much as I can to expose you to research, because I see that many classes doesn't, it's just more theoretical stuff, so that's what I tried to do. I tried to teach you the basics of reliability so that you can understand. By the way, there's a lot of stuff that you can do in reliability, but I didn't teach them in this class, so I can expose you to more applications. So I did some theoretical, and I try to teach you some softwares like ArcGIS, and try to teach you some coding, because that's why you have to use it. You are gonna do research. As I said before, doing PhD, it has to include some coding. It has to have an idea, and this idea is related with mathematical formulation. And you cannot solve it in your own, and you have to develop your own code to solve it. Okay? So, and I exposed you to publications and how to write papers, or what you should publish in papers, how does the results look like, and how to include multiple pieces of research that maybe you haven't done this research. You can build in other people's research, such as the population allocation model. You don't have to develop the code. You can just use it directly as is and include it in your own research. Like you can use the population allocation model in a bridge research, okay? In a building damage research, whatever research that you want to do. So yeah, I tried as much as I can to do this. So I hope that you guys use this in the future. Right now you have until next Tuesday to finalize your presentation, and for the final report, I'm gonna tell you exactly, I'm gonna send an announcement when I need the report, when it's gonna be to you. Maybe a little bit, few days after the presentation, but I'm sure it is not beyond the end of next week. Okay, so we will see about that, all right? Does anybody have any question? Well, at the end, it was nice to have the class with you, and I hope that you guys learned something. And if at any point you have a question, even right now or in the future about this stuff you're gonna use in future research, I'm here, just ask me whatever you want, right? Okay, right. See you guys somehow, somewhere, I don't know.